Hi there, today we're going to learn about waves, what they are, how they move, and why they're important. Well, don't worry, we'll keep it easy, and you don't need to know anything about waves yet. Just sit back and follow along. So, what is a wave? A wave is a movement that travels through something, like water or a rope, and carries energy from one place to another. When we talk about waves, we don't mean the thing itself is moving, but the energy from the wave is traveling. So, look at this rope. When I move one end up and down, the movement travels through the rope, and that's a wave. Waves can happen in any places, like in water, sound, or even light. But today we'll focus on the simple waves you can see in a rope or a string. So, how do waves move? Waves move in patterns. For example, let's think about a trampoline. When you jump, you push down, and that energy spreads out, and the trampoline moves up and down as the energy from the jump travels across the surface. Similarly, when you move a rope, one end of a rope up and down, the energy travels through the rope, causing the rope to move in waves. It's like creating a ripple effect on a pond when you throw a stone in. So see how the ropes moves in different shapes? Those are waves. And we're going to learn more about how they move and what makes them move. So, there are two main types of waves that you should know about. First, the transverse waves. This is when the waves move up and down like the rope I was holding. The movement is at a right angle to the direction of the wave is traveling. So, see how the rope moves up and down, but the wave moves along the rope from one end to another. That's the transverse waves. Next is the longitudinal waves. Well, these waves move differently. Instead of going up and down, they move back and forth. Well, sound is a great example of a longitudinal waves. When you speak, the voice creates vibration in the air, and those vibrations move out as a wave. Sound waves are likely tiny pushes and pulls in the air, moving forward like a wave, but without the up and down motion that we see in the rope. So, all waves have a few important parts. Let's break them down. First, the amplitude. This is how big or tall the wave is. The higher the wave, the bigger the amplitude. It tells us how strong or powerful the wave is. Next, the wavelength. This is the distance between one part of the wave to a same part of the next wave. For example, the distance between one peak of the wave to the next peak. Next, the frequency. This is how many waves you can actually cause when pulling one end of the rope back and forth. And all of these things together tells us how a wave behaves and how fast it moves. Waves don't just move, they carry energy. Well, imagine pushing a person on a swing. Your push makes the swing move, and the swing moves back and forth just like a wave. So the energy from your push travels through the swing. Similarly, when you move one part of the wave, it makes the next part of the wave move. The wave carries energy from where it started to the place it's going, whether that's in a rope, water, or even air. And every wave, no matter where it happens, carries energy that can be used to do things, for example, like make sound or move water. So, waves can also bounce back when they hit something. This is called reflection. Imagine throwing a ball at a wall, it bounces back. The same happens with waves when they hit something they can't pass through. The wave comes and reflects back, creating a new wave in the opposite direction. Another cool thing about waves is how they can meet each other. Well, sometimes when two waves meet, they can combine in two ways. First, constructive interference. This happens when two waves meet and make a bigger wave altogether. It's like when two people push a swing at the same time, they make the swing go even higher. Second is destructive interference. This happens when two waves meet and cancel each other out. If one wave goes up and the other wave goes down, they cancel each other's movements, making the wave flat. Well, both of these can happen in all kinds of waves, not just on ropes. They're important for things like noise-canceling headphones, which use destructive interference to cancel out unwanted sounds. So, did you know that waves travel at different speeds? The speed of a wave depends on what it's traveling through. For example, sound moves faster in water than in the air, and the speed of the wave doesn't depend on how loud or quiet the sound is. It just depends on what the wave is traveling through. We can also figure out the speed of a wave if we know its wavelength and frequency. Speed equals wavelength times frequency. So, if a wave has big wavelength and high frequency, it will travel even faster. So, today you learned a lot about waves. We talked about what waves are and how they move, the different types of waves, transverse and longitudinal, and how waves carry energy, reflection and interference, and the speed of waves. So remember, waves are everywhere. They help carry sound, move water, and even let you see light. So the next time you see a wave, you'll know exactly how it works. Well, thanks for watching, and I hope you learned something really fun today. See you in the next videos.